Hi everyone. This is a video of some of the quiz 4 review questions that we went over or were on your review sheet. I realize a lot of you had to miss class this week for different reasons, and I just thought it might be helpful if I made a video to go over some of the problems that students had questions on. All right, so question number 1 was a review, and it asked you to graph the equation, okay, or graph the function. Now, we can tell it's a linear function because the highest exponent of x is 1, and I can see that it's in the form y equals mx plus b. M's the slope, and then b is the y-coordinate of the y-intercept. So I have suggested to you that you always write those two values down. So the m, or the slope, is negative 2/3. And that tells me I have a couple options here. I can see how we've got that negative 2, so that means go down 2, and then the 3 is positive, so we could go to the right 3. Now, we could say that that negative belongs to the 3, and we could go up 2, but if we go up 2, that's a positive direction. We would need to go to the left 3. So I'm just going to work with this one. So there's my slope. And then my y-intercept, I'm going to write it down, is the point 0, 1. Remember, b is just the y-coordinate of the y-intercept. All right, so I'm going to go to my y-intercept of 1, and then I'm going to use the rise and the run, the down 2 and the right 3. So I'll go down 2, there's my down 2, and to the right 3 units. And then I'm going to go down 2, 2, and then right 3. And then down 2, and to the right 3. And so I have a line that is descending from left to right. I'm going to try my best here, guys, to get it through those points. You will probably be using a ruler, but I'm using my smartboard. And there's my line. I'm going to put arrows at the end of my line, indicating it goes on forever. And so there I have my line. And that is how I graph when I'm in slope-intercept form, y equals mx plus b. Now, the second example is in standard form. Remember, it's in the form ax plus by equals c. Now, you easily could manipulate this and put it into y equals mx plus b, but we've also talked about the fact that sometimes it's just easy to use the intercepts. So if I want to use the intercepts, I suggest we make a table. So our table would have an x of 0 would give me my y-intercept. So if x is 0, we get 2 times 0 minus 6y equals 12. This kind of goes away. So then y equals negative 2. And that is my y-intercept, 0, negative 2. All right, my x-intercept, I'm going to let y be 0. If y is 0, that gives me 2x minus 6 times 0 equals 12. That goes away, so x equals, in this case, 6 when I divide. And so that's my x-intercept. Those are two coordinate points. I plot them, 0, negative 2 on the y-axis. Remember, that's my y and that's my x. And 6 on the x-axis, 1, 2, 3, 4, 5, 6. Got these 2 points. I take my line, and I'm going to draw my line. Through those points, I'm going to put arrows at the end. I usually ask you to go off the graph, but I have a little space here, and there's my line. You will have to be able to graph, especially because we're going to be moving into linear inequalities soon. All right, another question that I looked at that I thought might give you some challenge is when, what this quiz is really on is on inequalities, okay? So in part 2, I looked at some basic inequalities. So I'm specifically going to go over number 4. Now, number 4 I love because it's got fractions in it, and we've talked all year about how the best way to handle equations or inequalities with fractions is to clear them. So look for the lowest common denominator, which is 4, and then multiply the whole equation by 4. And in doing that, I got 4 times x, which is 4x. 4 times negative 5 halves is going to give me negative 10. Now, if you need to do that on the right here, remember, we put the 4 over 1. 2 goes into 4 2 times. 2 times 5 is negative 10. All right, that's greater than 4 times 3/4 is going to just be 3x. And then 4 times 9 halves, 2 goes into 4 twice. 2 times 9 is 18. Then you can simplify the inequality. Remember, we always want the variable on the left, so I'm going to bring that 3x to the left side. I'm going to add the 10. And that's going to give me x is greater than negative 8. I go graph that. So here's -8. I want all x's greater than that. Open circle because it's just greater than. So every answer greater than -8 would satisfy this inequality. All right, moving on. We moved on to compound inequalities. You want to be able to identify that this is maybe we called it the 3-part inequality. This is an and inequality, which means it involves overlapping regions. Ands involve overlapping. So then we can solve it. We can actually solve it pretty quickly in this form. We don't have to separate it. We can solve it simultaneously by adding 1 to all 3 parts. That's going to give me -1 is less than 2b, less than 6. And then divide by 2. And we get -1/2 is less than b is less than 3. All right, I want to graph that. So I want all the b's in between those numbers, all of them. Oh, and this was equal to. So I have an open circle and a closed circle. So it actually includes the number 3 as a solution. All right, then we had some that involved or, okay? So here we have an or inequality, which means it's one or the other. So we don't have to look for overlapping regions, but let's look at this. If I divide by a negative, we know we're going to flip the direction of the inequality sign. So that's going to give me x is less than -3, or, because or is part of my answer. So anything less than 3 will satisfy the equation. Or subtract 12, and I get 3r is greater than or equal to -12, and I'm going to divide by 3. And that's going to give me r is greater than or equal to -4. All right, so I'm going to go to graph that. And here we've got -4, and I want greater than. And I've got x is less than -3. That's actually over here. Okay, so now if this is an or inequality, it actually covers every single number. Every single number on the number line would satisfy either of these equations. So this is a scenario where we have all real numbers. Remember, ors, we're not looking for the overlapping region. We're looking for everything in the set. So all real numbers. Now, if we look at number 8, that's a difference. This is an and inequality. It's not written as one compound inequality. It's written as 2 separate, but using the word and. And means that I have to be looking for overlap. So if I divide each side here by -2, I get m is greater than -2 and subtract 12. So 2m is less than -12. So m is less than -6. I go to my graph. I get x is less than -6 and x is greater than -2. There is no overlap. No overlap. And it was and. So since we have no overlap, that means there's no number that's going to satisfy both of these equations. So there is no solution. All right, so those are the ones that get tricky, so I wanted to go over those. We moved on then to absolute value equations. We talked about absolute value being distance on a number line. And so because it's distance, we have to consider that we could be going to the left a certain distance and to the right a certain distance. Then we walked through the process of how we might best solve these. And so remember I said you want to first isolate the absolute value bars, remove them and then separate them into 2 equations, solve each equation and graph. And we're really looking, for the most part, we're going to always have 2 solutions, 2 numbers that will make the equation true. There's only a couple cases that won't happen. So I'm going to isolate by subtracting the 1. So now I have the absolute value of 3x minus 2 equals 4. Now I'm going to separate and solve. So I get rid of the bars to solve. So 3x minus 2 equals 4 and 3x minus 2 equals -4, meaning I'm going either to the right 4 or to the left 4. Now we solve each equation. So we're going to add 2. So 3x equals 6 and divide by 3. So x equals 2. Sorry, I had to get small there. On this one, 3x minus 2, I'm going to add 2. That's going to give me 3x equals negative 2. And then I'm going to divide by 3. And so x is equal to negative 2/3. So my solution is just those points because it's an equation, not an inequality. Okay? All right, so isolate, separate, solve, graph. Okay? Now, I'm going to jump to question 11. Houston, we have a problem. If absolute value, I want you to really think about these before you jump in and dive into these. If absolute value means our distance on a number line, and anytime we put a number into absolute value, we're going to take out a positive number. Can this be a true statement? Can you take the absolute value of a number and output a negative 7? I hope you're saying no, and we talked about that in class, so this answer quickly is no solution. All right. Last absolute value I want to talk about is actually writing an absolute value equation from the graph. Now, we talked about how that the absolute value equation involves two things. The middle point, I called it the midpoint, and the distance from that point to each of the endpoints. All right, so first we want to find the midpoint. Now, if you're given a number line with no marks on it and you can't just easily count, we said that to find the midpoint, you find the average of the endpoints. The average of the endpoints. Okay, so to find average of two things, we add them up and divide by 2. So that's going to give me negative 6 divided by 2, which is negative 3. So my midpoint is negative 3. And you can clearly see that the distance to each of my endpoints is 5. Okay, so that would tell me that my absolute value equation would be x plus 3 equals 5. All right, and you could always check by solving to see if that's actually true. All right, then it moved on to review questions. If you want, you can see the solutions guide for this as well. But I do want to go over. This question number 14. Okay, so it asks to write an equation of a line that passes through the points 7, 1, and negative 3, 1. Now remember, I have said to you the minimum you need to write an equation of a line. So the minimum is a point and a slope. A point and a slope. If you don't have a point and a slope, you cannot write the equation of a line. All right, so because those are the features that we need to graph lines. All right, so I have 2 points, but I don't have a slope. But because I have 2 points, I can actually find the slope. So I'm going to use the slope change in y over change in x, or y2 minus y1 over x2 minus x1. So that's going to give me 1 minus 1 all over 7 plus 3. That gives me 0 over 10. Yikes. What does that mean? Well, we've been talking a lot about the fact that when 0 is in the numerator, it equals 0. So if 0 is in the denominator, we get an undefined slope. Since that's one of the special slopes, slope of 0, I hope you're starting to think, hoy vox. A horizontal line has a 0 slope, and its equation is y equals one of the numbers. Y equals a number. Well, it equals the y coordinate that it goes through. So y equals 1. All right, the last thing I want to talk about is using the slope to find missing values in tables when they represent a linear function. So remember, slope and linear functions have a change in y, a constant rate of change. So a change in y over a change in x. So if I look at my change in x here, I can tell that my x's are, in this case, going up 1 each time. And my change in y's, my y's are actually going up 2 each time. So if I'm going up 2 from negative 1, that would put me at a coordinate of 1. All right, that same idea we can use to work backwards. I'm looking for this coordinate of y. So I'm actually looking for the y-intercept. That's interesting. So I look at the change in y here. So this is going up 1, up 1, up 1. And the change in x is going up 3, up 3, up 3. But on my table, I actually want to work backwards. So instead of adding 1 to go back, I would have to actually subtract 1. That would give me the 0. So from 10 to go backwards, I'd have to subtract 3, putting me at 7. All right, hopefully that helps, and I want you to try C on your own. So that was a quick review of some of the problems from your review sheet. If you want any more, just let me know, okay? Have a great day.